I started. Wait, it says recording pending. Oh, there we go. Now we're recording. All right.
How do I screen share?
There should be a share content thing in the top right-hand corner.
Okay. Is it sharing?
Yeah.
Give me a second. Okay. Should we start?
I guess so. I mean, nobody had any questions about getting Inventor, right? All right.
All right. Kashyap, are you recording?
Yeah, it's recording.
Okay. So this is the introduction to Inventor sketches for CAD, and after this, you guys should probably try to play around with CAD. I'm sure some of you already know how to CAD, but if you don't, it's good to start practicing. And you can email any of us to see if you need help on learning how to CAD. All right. So you start here at Start 2D Sketch, and it will show up. It'll show 3 different planes. There's the X, Y, and Z plane. Usually we start on the X and Y plane, but you can also start on the Z plane as well. Yeah. There are 4 different tools here. There's the line tool, which makes lines. There's a circle tool that makes circles. There's an arc tool that makes arcs, and there's a rectangle tool that makes rectangles. And there's a drop-down tab here. I don't have a photo of all the different options, but for example, there's this one up here, which is a center point rectangle. You can place a center point and drag out, and it will create a rectangle or a square around it. And there's also another one where you can start here and drag out this way and create a rectangle from a corner. But it's usually good to start from the center of the plane because we want our CADs to be as symmetrical as possible, because it's much easier to work with designs that are more symmetrical, and also it's easier to mirror a part that is centered across the plane. This was made during rectangle tool. You could dimension both sides. This is 2 inches by 2 inches, and the black lines mean that the part is completely dimensioned. It can't move. It's constrained to its spot. On this slide, this is using the offset tool. So by offsetting this square from the original one, your part will change. If you set a distance between the 2 squares, the size of the second square will change in correspondence with the first square. So this is good because often you'll have to change the dimensions for parts when you're iterating your designs. So if you're using the offset tool, instead of creating 2 squares, by changing the first square to maybe 3 by 3, this second square will change with it depending on what distance you set between these 2. And you can also set an equation for the second square based on this one to change with the original square as well. Okay. This is the original square extruded, which makes it into the 3D object. And another sketch was started on one side of the part. And this line here is called a construction line. It's made with this line and this tool. And I think Jonah will talk about what construction lines are in a later slide. But we use this line with the mirror tool here. So we use a slot. Well, Sadesh did. Sadesh chose the slot and he created it here, dimensioned the circles and the length, and mirrored it across the construction line onto this side. And this is good because, again, symmetry, and it's also much easier and nicer to look at to have the dimensions on only one side and know, oh, it's mirrored on the other side. It's a cleaner sketch, and it's good for us to use and to understand. This is it extruded. So if you extrude it by selecting the inner slots, if you extrude it this way, it will add material. What would the shape be? I don't know, but it'll add material, but if you extrude it this way, it will subtract material from the part that you already have.
Okay. So this is an example of the rectangular pattern tool. There are different pattern tools like the circular pattern tool and rectangular, and basically what it is it allows you to create a pattern with any drawing that you have on a certain plane, and basically like repeat that pattern. So the rectangular pattern tool, it shows basically you can choose how many times it repeats and the distance between the gaps. Next. This is just an image of it extruded. As you can see, the circle, we did the rectangular pattern tool with the circle on the whole rectangle. Okay, so this is like kind of hard to see, but around the outside of the circle, there is construction lines of a square. Basically, construction lines are they're basically lines that can act as guidelines. They're not part of the actual sketch, so when you extrude, you won't be extruding construction lines. They're just invisible lines that help you define other parts. And yeah. This is just more examples of the offset tool that Chanel talked about earlier with circles. Okay, so this is an example part of just like a plate with like cutouts for holes and for mounts, basically, for like a motor or whatever. Next slide. So what we do for some of our parts is we cheese it, or that's what we call it, and which is basically if we want to cut out material or like lessen the weight of our part, we would do a bunch of offsets around the holes and make kind of connections between I don't know, it's hard to explain, but we can explain it later.
It basically ends up looking like that. So it just reduces weight basically.
Yep. That's pretty much all we have for this presentation, but I urge everyone to try it out yourself. Just go to Inventor and play around with it. That's probably the best way to learn. And if you have any questions, just ask us.
I can actually screen share another example of a plate from our 2020 season that I think is like a lot of what you showed in your presentation. I don't know if it's sharing, but this was okay.
Oh, and also a quick plug. Sidish is doing like quick informal workshops where he just like screen shares in CADs on Saturday, I think. So you should show up to those. Those are pretty good. And we're going to be working on a curriculum for those.
Okay, wait, so is it not sharing? Or is it sharing?
Not.
Well, it's just a black screen.
Okay, let me try again. I'll just share my desktop screen then. Is it working now? Yeah. Okay, well, so this is one of the plates that I don't think Sidesh likes very much. It's called Michael plate. It's an awesome example of our nomenclature system from last year. But now it looks pretty messy, and that's because honestly kind of is, but there's some like important things that I want to talk about in this sketch. So before we get to all of this like mess in the middle, which if I click finish sketch, you'll see like that's the actual body of the sketch. One cool thing you can do with sketches is you can like model the environment that you know your part is going to be working in. So this rectangle right here, I'm clicking the bounds of, that's 5 by 3.25, represents the bumpers of our robot. So basically, because I know that this is my intake plate and I want it to sit like in front of my bumper, I'm basically, what you can do is you can model some of the things that exist like in your environment that the part is going to have to be around, but like you're not actually going to include in the part, so that you can still have their dimensions there and work around them. Yeah, and another example of that is these two rectangles right here, which are not actually rectangles. They represent the wheels of our center mechanism, which I knew was like about 1.23 inches back from the end of our bumper on our 2020 robot. So another thing is here's a construction line, right? And one thing I really like to do when I'm doing these kinds of sketches is create a construction line that represents the ground. So in general, I don't know if I would necessarily call it like a best practice, but it is a practice you can use. I'm sure some people would disagree with me, but personally, I like to have like one point in the sketch that everything can be referenced to, rather than everything being like referenced to itself. That's like a concept we'll also cover in assemblies, where you usually have like one part that's grounded, that like doesn't move, and everything is referenced relative to it, because when you're working in CAD, there's no like ground or gravity, or I guess something that defines what's up or down. So you need to, I guess, think of defining that yourself. So here we have our ground, right? What I have here is, you see that this constraint right here is 5.5 inches. And the reason it's 5.5 inches is that in prototyping, we determined that 5.5 inches from the ground is like the best compression on the ball, or I guess the optimal 1.5 inches is the optimal compression on the ball for intaking. So that means that the ball, which is 7 inches in diameter, needs to be put through like a 5.5 inch space. So I took this circle that represents one of the rollers we have on our intake, which is 1.5 inches in diameter, and I created this construction line, which is, if you see here, it's tangent to the wheel, or tangent to the roller, and then I put that 5.5 inches from the ground. Then each roller is basically, there are also tangent, that's just for like, actually, that has a purpose as well. So you'll see that the distance between this other roller and this roller is also 5.5 inches, because we want to maintain that same amount of compression. This one's about 6 inches, because at this point, we're not really trying to like intake the ball from the ground, we're just trying to move it through. But at several points in the sketch, you see 6.25 here, for all the rollers, we're basically trying to just think about how much compression needs to be on the ball, and then I guess the position of the circles is being adjusted by like those constraints that we set. In this case, that's a dimension. So you also notice that there are these like kind of weird looking dimensions here, like 5.512, 4.528. So originally when I start this sketch, right, I just I start with these constraints, the 5.5s, the 6s, the 6.25s, because that's what I want to reach, right? That's like the compression that we want to put on the ball. But in terms of these weird numbers, you might be wondering how we got those. Well, those numbers actually represent the center to center distance of the belts that are being driven from here to here. And I'm just now realizing it's probably a better idea if I pull up like an assembly of this, so you guys can better understand like what it looks like. So I'm just gonna pull up the complete robot.
Oh no.
Okay, awesome dependency error. I guess, so if you have a messed up file system, sometimes what will happen is what we're looking at right now, where basically Autodesk Inventor is like, hey, I need this file for the assembly, but I can't find it. So then you have to go manually reference it. I can't find it. That's awesome.
It's in 2019 FRC CAD / Offseason Robot - Neil Chanel Falcon. Like, it says there.
Why is
Why
it
is
referencing
it
an
the
off-season
2019
project?
FRC CAD?
Yeah, why did that happen? That's a really good question.
Why is it referencing an off-season project though? Like, at least
That folder doesn't exist here either.
That's 'cause
I
you
mean,
have to
isn't
download
that trying to import the Falcon itself?
Yeah. But like the problem with that is like the Falcon didn't exist in 2019.
Yeah,
So, like,
no. Use it
How
for
did
the
it end up in their
off-season.
2019 CAD?
Use it for the 2019 off-season.
I guess somebody deleted that while like
so you
cleaning.
need to download that.
Okay, well,
Don't
It's
worry,
fine.
this will never
Open
happen
without.
again.
it happens a lot, unfortunately.
Just open it.
Who needs a
We
common
don't need
library
Falcon.
version? Yeah, so
This entire.
what you're seeing here is we have some dependency errors in our CAD library that, quite honestly, Sadesh has been working to fix, but we're still having some issues with that.
Which is why it's so important you all should learn how to CAD well so that we don't keep running into these problems.
Not just CAD well, but like do proper file management, which we didn't really have. Okay, so let's look at
don't do what Kashyap says.
smart. But basically what we have here is the actual assembly of our intake, and if you look here, I guess let's take a quick look this side. You can see that these are the two wheels I was talking about in the sketch. This is the bumper I was talking about. So we took like the cross section of them and we put them in our sketch so we could like work around that. And you see here, right? We knew that we wanted to use these types of rollers to bring the ball in because like that's what we had prototyped, right? And then also knew that we had to find some way to like connect these rollers to one central motor to have them all powered. So the way that we decided to do that was a belt drive. So each of these little like things with teeth are timing pulleys, and they have little timing belts that run along them. I actually think I have the timing belts for this at my house because I ordered them for like the second version of our robot. I don't know if you guys can see them on my camera because we're gonna build a second version, but then like quarantine happened, so they're just like chilling on my desk right now. But basically these little timing belts, they go from pulley to pulley, right? You can see that these also have teeth, and the timing belt engage on a timing pulley. I guess just like how two gears would engage together. Not exactly the same, but they're pretty similar. What that allows us to do is we have one belt from the motor here, which is mounted to the plate, all the way to this, and then from there to there, there to there, there to there. Now the thing about a timing pulley is if you look at this, there's like only one length, or I guess multiple lengths depending on the diameter of the pulley, but there are only very specific lengths that the the distance between these two pulleys can be. So if you like properly define what you want in terms of like the height, I guess, relative to the points, like for example 5.5 up here, and then you define based on like the pulleys here, I knew that this pulley had to be like a certain number of teeth, so it wouldn't be bigger than like whatever tube we were using. Then your sketch will almost, I guess, begin to define itself because you've given it you've given Inventor enough information that like these circles basically move into this position because there's only one place that they can be based on how many constraints you've given them. And that's a technique I really like to use with sketching because I guess at the end of the day, if you just give it the constraints that you know you need, you're going to end up with something that meets your constraints. Some other things that are a little less relevant to that, I guess, are, I mean, this is another example of a belt run. You'll see I model the belt runs once again with center construction lines. I don't know why this one's oh yeah, actually I do, never mind. So then here's an example of a motor. You'll see that it has this one like square pattern. You could either do this using a rectangular pattern, or if I take the rectangle tool and I just do a 2-point center rectangle and I make it out of construction line, go. I have a nice rectangle. If you use 2-point center instead of regular 2-point, then it automatically creates like diagonal lines, and you can manipulate it by its center point, which is a lot more useful if you're trying to create something with like a circle in the middle and like, or even just like holes on the ends like this, which is how all of our motors are mounted. If I come over here and I open up this motor, you'll see on the face of the motor, there's this pattern where the holes are 1.396 inches away from each other. It's actually closer to like, I think, √2 inches from the center to here, or like across. It's like a really weird dimension actually, but
it's a 2-inch bolt circle.
Yeah, which is why like it's √2. So what you would do is you take the bolt circle that's specified on Vex Pro, which is the maker of the gearbox that it goes into, and then you replicate the same pattern inside your own Inventor and place it here. Yeah. And then also things just like mounting holes. Like mounting holes are just like holes for screws, and that's literally just a circle, and then you don't extrude that circle. So if I go into my extrusion menu, I know we're probably going to talk more about extrusion and stuff next time. You'll see the only part I extruded was, like, I guess, the part that I intended to be the plate. Like, I could extrude this too, but I know that's part of my bumper, so I don't want to extrude that. So you can, like, select it. You can use a lot of extra lines to, like, construct something, like, construct geometry, but then you don't have to end up extruding it later. For example, this one has, like, a lot of really weird parts extrusion. I can just go like that, and that part won't be extruded, that part won't be extruded. Basically, anywhere you have like a closed loop or like a closed shape, you can extrude it. The next part of that is, I guess, here's the cheesing. This is less relevant, but I guess it looks cool. We mainly cheese for lightning and aesthetic purposes. This plate never actually ended up being lightened because we made it out of plastic instead of metal as originally intended. So it's already lighter. Also, like, the plastic probably would not have done well with this level of lightening. It probably would have bent and snapped. Like, overall, I guess the thing to take away is you can do a lot of cool things with dimensioning and sketches, like these tangent constraints with circles, to define the geometry of something like this, so that I guess you don't really have to do as much work, and you can let Inventor do the work of the placement, because it'll just figure out this is where this goes. Yeah.
And sorry, if I could add something, if you wanted to go back to the sketch too, that would be cool, okay, because it just shows better. But when you're making a sketch, and like what Kashyap said, you can add all these extra lines. What helps, I found, in when you're trying to extrude it, is you can there's a tool up top that's called split, and you can like split different lines and then turn different lines into construction lines, so that like you can yeah, when you turn that into construction line, it doesn't give you the option to extrude it, but like it keeps it in the sketch so you can see them visually. So like in Kashyap's example, I would probably do that with the centering wheels and with the bumper and those kind of things, so that you don't have any problems there. Like,
yeah, there are definitely a lot more lines in here.
Extrude.
There are definitely a lot of lines in here that probably should have been construction lines, but I like kept them as what's it called? Solid lines, because I just like, when I was working on it, I couldn't really see the construction lines very clearly, so I never changed them back. Like, you see, I have this like big square around it. And that was just actually to create closed loops. There were some places where it just wasn't extruding properly. That's a CAD practice you probably shouldn't replicate, because I don't think it's very, what's it called, maintainable if I make changes to this part. Oh, okay, that's a big thing. So in general, when you make a sketch, right? So something like this, if I change a value, there's not an error, right? It just changes how the plate is shaped. Now, that's usually how you want to make a part. In general, like if I make a sketch, I say these are, let's say, 1 inch apart, right? But then if I put another thing on it, let's see. I make this 1.5, but then I want to end up changing this. I don't think it'll work unless I'm, sorry, I need to. Oh, this is an example of another constraint. So you see here that there's a horizontal and a vertical constraint. So if I use the vertical constraint, there we go. Now it'll over-constrain the sketch. Oh, that's because we're horizontal, but our vertical. But I mean, these two tools you can just use to like basically snap a line into like a certain direction. Because like for example, if I make a line like that, this is just going in like willy-nilly in any direction. If I use a horizontal tool, it'll make it. I know this is a little counterintuitive. It'll make the horizontal tool. It'll make it vertical because of the plane we're on. I think if you look in the bottom, you can see your coordinate axis. This is X, this is Z. We're like upside down right now and to the side. So to Inventor, what's horizontal is actually vertical to what we see, and what's vertical is actually horizontal. But you see those are like cool tools for doing stuff like that. Also make like a perpendicular line with the perpendicular tool, parallel line with the parallel tool. So like, if you're making like sketches that you want to follow certain rules, this little like 3x4 box is really useful for things like that. Collinear is also really, really useful, but I don't really think there's a use for it in this sketch. So let's see what happens when I try changing this. It should tell me that I can't. It's not telling me that I can't.
It's because you haven't dimensioned them.
I haven't dimensioned
the Y. You've dimensioned the X. Yeah.
Wait. I need to think about this one. I'm going to dimension the Y here.
No, try pulling the center of one of the circles out and then dimensioning the, yeah, because they're just not. Wait. Never mind.
Yeah, I think I need to fix something. Like, literally fix it. No, it's already fixed. Okay. All right. This is fun. When's it gonna tell me now? It's just.
You haven't dimensioned the height of the rectangle, so
yeah,
you're contributing to it.
Yeah, because it's, let's see, if I drive it to the height and I just go. Now it should be able to move. Oh yeah, wait, driven dimensions are really important. So one thing you can do that's really cool with dimensions is if you look here, right, each dimension, this one's D6, this one's D2. Inventor actually allows you to create functions using each dimension. So for example, if I didn't want this to be 1 and rather, let's see what these ones are. These are D0 and D1. You know, D0 plus D1, except now it should actually give me an error. Fail to edit dimension value. So the reason it's not letting me edit the dimension value is because if we look at everything here, right? This is 1.5, this is 0.25, this is 0.25. So this can't be anything times 1, which works if you're just trying to create a sketch for the first time, right? Well, let's say I check the part again. I'm like, oh no, this actually needs to be 0.75. Now I need to change 2 values instead of 1. If I were to remake this, how can I remake it to make it better? This is what I was talking about, where usually I feel like it's better to dimension from one specific corner. So let's choose the bottom left corner, for example. So from the bottom left corner, I'm going to say this one's 0.25, right? And then it's 0.5. And this one's also 0.5 from the bottom left corner. From the bottom left corner, this one's 1.25. Or I guess I'm going to make it 2.5. Or what you can do instead, if you just want these to stay this far apart, is you can make it so that this one is D9 minus D10. So if you drive the, what's it called? You know these are always going to be like the same length from the end, right? But now I can change this to 1.25, and you can see that the distance between these two has moved to 0.75 or whatever I wanted it to, with only needing to change one dimension. So sometimes it's better to not really over-dimension a sketch, or I guess keep it more flexible. And using driven dimensions, you can create sketches that are more flexible. So if you need to make changes, you can make them easily and without errors. Hopefully, in the future, I can give you like a more cohesive example for that one, like with one of the examples of a barn or a robot, where I know we. But I don't know if that one's gonna be like a ramble if I try and explain it right now. But like overall, yeah, those are some other cool tools you can use while sketching. Parth, do you think there's any other tools that you think that'd be pretty simple to fit here? I guess maybe Mirror I could explain here.
I think didn't Chanel and Jonah, they explained it during in the presentation, I think. But okay. Also, I don't think we talked too much about, but I don't know how. I mean, yeah, I have to make some
like
lines
pretty
to fit
important.
That in. Yeah.
I feel like from what we've said so far, we should get them to start trying to download Inventor. Siddesh sent a link earlier. I'll send that again in chat to a video that oh, it wasn't a link. It was just the video.
Yeah.
Yeah, here, I'll send the link in chat.
In the meanwhile,
so I guess we'll think of something to give you then. Let's see if you guys can make. I just realized I'm like showing you guys, but a 1x1 square. Made out of construction lines with circles on every corner. I don't really think we're gonna have you guys use the arc tool, because I'm not gonna lie, the arc tool is not very intuitive to use. I wouldn't really recommend like starting with it. Here's another example where it's like really good for driving. Individually, I can change so let's say I want a 1032. Now they're all the same. That's like probably the best example I can think of for when we drive the dimension literally every time. we know all of the holes in a hole pattern are the same, so we drive all of them to the same one. But in general, do you guys think you can make this at home after today? It's just a square, I guess 2 squares with some circles on the inside. I'd say that's a pretty reasonable expectation. So I guess today or even before next meeting, try and see if you guys can make this. If you don't have Inventor, you can even try using like Onshape or something. I don't really think the sketching is that different, but try and get Inventor. Okay.
Okay.
Mainly what I have.
I have a question.
Yeah.
So the Inventor doesn't work on Apple laptop, right? On Mac?
Yes. So you can use Fusion 360 on Macs, and most of the files should be compatible. It's really similar because it's also by Autodesk. Or in your situation, you could also use Onshape if you have a Mac, and I'll send.
Here, if you have a Mac, you can do dual boot, between Mac OS and the Windows. Then you can use at the Windows. At Apple, most of us have a dual boot because most of engineering tools they develop on Windows. Then because Windows have a bigger market share than Mac, that's why you can do dual boot. Then you can switch it between Windows and Mac OS. It's really easy.
Yeah, thanks.
Okay. Chanel, would you mind sharing the presentation again for a second? I would like to. Things that should make it easier for us to do systems management when we eventually get to that point. I think we have a presentation on that coming up. So if you
share.
Yeah, this is good. The second slide, I think. So I know we said earlier that when creating parts, most of the time XY is our go-to. That's not exactly a great practice. I know we've been doing it in the past, and quite honestly, we should probably stop doing that. And the reason is just every time you place a part that you've made from a sketch, that part is based off of this original sketch, right? So if you make a part off of your XY sketch and it ends up being oriented a different way, you're going to have to rotate that part in your assembly. And that means that every time you want to place a new part or a new version of that part, you are also going to have to do the exact same thing. Backwards compatibility gets incredibly hard to do the versions of the same part over and over again, right? So let's say you're making a tube that's oriented from the front of your robot to your back. And for reference, Chanel, can you show where we put the front of the robot in the assembly, just off of this grid with the pointer? Yeah. So we generally place the front of our robot on this line of the assembly. Yeah, thanks. And the back would be on the opposite end of that, right? So if you have this from the front of your robot to the back, you would want to create it using your center. If you could tap on that screen, that would be nice. Yeah. So you want to orient it such that when you actually create the part, that part you don't have to reorient it in your assembly. Again, it just makes it easier when you have to install a new version of that part into the assembly. It's a whole lot less work once we get there. And we'll explain why this is important in a future workshop, because that's not really something for this one. Backwards compatibility is also why we want to have nice and neat orderly sketches, so that we can modify things after they're actually created, instead of having to create a new part every time you want to make a small basic change. Less is more with constraints. It's just easier to modify them. Just tiny things like that. Okay, yeah.
Okay, other than that, I think Sadesh posted a video in this channel actually on Microsoft Teams about how to use Inventor, or how to get Inventor, I believe. So I would say probably watch that video if you're like really having trouble with it, or you could actually just like contact any of us either by email or through Teams, or I guess even through like iMessage, because most of our like iMessages are just like our name dot our last name at warriorlife.net.
So to find Sadesh's videos, just scroll up a bit in the CAD channel, or also I replied to this meeting with the link to that, so you can just use that too. And
okay.
In that case, I think we covered everything.
Yeah.
So I took a screenshot of Kashyap's sketch, and if you are able to download Inventor, please try to play around with it, and you can try to recreate what Kashyap did. And if you need any help, just ask someone for help. Anyone's willing to help.
Yeah. So I think I'm gonna stop recording now. I actually don't know how to stop recording. Oh, there we go. Stop recording.